Hello to everyone. It's great to be back. Today we have B.Tech Computer Science, Data Science in focus. On that note, it gives me immense pleasure to welcome Dr. D.C. Kiran.
Hi.
Hello, sir. Dr. Kiran is a founding faculty member of the School of Computational and Data Sciences at the Vidyashilp University and also the founding registrar at the university. Dr. Kiran is an associate professor at the school and has 24 years of experience in the field. Great to have you, sir.
Hi. Thanks for the invitation.
Thank you, sir. Sir, I'll just like to share a bit of context. I myself come from BE in computer science, so it's a special honor to have you here with us today. I think I can relate to a lot of things I learned in my undergrads long back, around 2 decades back, and would definitely love to know how things have evolved over the past 2 decades. So, sir, being in the industry, we hear about a lot of things happening around, like companies like Nvidia coming in, becoming great. We hear about AI revolutionizing the world. We also hear about SatCom coming into India and how the world around is going to change. So, how do you think is the industry evolving? And also, would like your views to understand how the classroom is evolving to keep pace with the dynamic evolution of the industry.
Yeah, great question to start with, Rahul. As we are witnessing, as the technology is growing in a very rapid pace than what we have experienced in the past. And there are a lot of transformation which are happening, which are driven by the breakthroughs of AI technologies, ed technologies, and accelerated computing also. Many times we forget about the accelerated computing. We talk more about data science and AI. As you were talking about Nvidia started with GPU to power the AI things or parallel programming, high performance computing type of things in the past. Now they are not limited to it. They have evolved to build the infrastructure for the AI domains using the LLM or agentic AI type of thing, whatever, or the robotic applications real time which need dynamic and real time outputs, which we need to, as a bit of computer science, we need to get evolved to that phase. We need to accelerate ourselves to teach to that phase. Also, when you talk about the communication, now the digital division what we had, the rural area and the urban area are connecting to the any part of the world, which we had a divide. Now that has been covered. It has been bridged now. So we need to take advantage of those things, not only in the industry, but we need to take that advantage in the classroom teaching also. Right. So in this dynamic landscape, now challenge of teaching students in the undergraduate program of B.Tech Computer Science is not limited to teaching the programming. Now a day has come where we started telling that anybody can write a program if you understand the problem. So what we need to take into class is to enable students to identify the problem, solve the problem, and to work with cross domain. That is very much important. It is not only Zolo thing where we teach only the concept of computer science. We need to teach them to think across the domain. I personally believe that we need to inculcate research in the classrooms. What I mean to say research here is that we need to take research into our teaching. It is not expect some publication from the students. I'm not telling that. We need to teach students how to frame the research questions when the concepts are taught. We need to teach them how to come up with the solutions for it. As a teacher, I need to daily I need to take some real-time data, real-time problems, or any projects what we are doing, we need to take into the class. So it is not that we teach from the textbook or from anything which are available in the internet. So that is the thing what we need to adopt in the curriculum what we are using in the classroom. So so what we need to do is, as industry requirement, we need to be the content whatever we are taking. B.Tech program should be more agile, it should be more relevant, and it should be very close to the outside world. That practically we need to take those things into the classroom.
Yes, sir. So, sir, again, reflecting back on my journey, since you have been into this teaching field for so long, as a student, I ask you a question. When we were students, all our teachers used to say data structures is very important. So, what is your take on data structures, and how important is it today? Because as a student, we felt it was most interesting also, but most challenging also. It involved a lot of thinking. What's your take on data structures in classes?
Very good question. Like again, many people, we fail to understand this the course data structure, which is a very basic and important mandatory course in the past, in the present, and in the future also. Right? Data structure is all about how are you going to store the data so that it can be retrieved fast, and every context is different. I should be knowing what structure I should be using. So maybe a static array, or maybe the dynamic linked list, or the tree type of thing, which is more efficient for a different application. If I am storing the student data, the speed at which I am going to retrieve the data may not be that efficient. But when I am looking at the bank applications, which need faster way of accessing the things, so we need to ensure that the structure where I can access the data quickly is used. As well as I used to teach one application like selling the insurance thing in the dynamic thing, right? I don't know, if I'm creating a platform where for the agent to sell the application, I don't know how much insurance he is going to sell. So I need to keep the data of the customer who is trying to buy the insurance. If I'm keeping those things in the cloud, now I'm relating data structure with the cloud now. So every data you store in the cloud, you need to pay.
Correct.
So you cannot go with the static structure. So per day 100 users, and you pay for 100 user, and you do business for only like 10 users you are doing, and you are paying for 90 storage without doing any sort of business. So you can relate data structure with the cloud computing also. So data structure was relevant and is relevant and will be relevant in future, right? So in Vidyashilp, we start as a basic course along with teaching the basic computer science, basic computer programming. In the second semester, we teach them the data structure. We don't carry in the past, we used to learn data structure when we used to be in third semester or fourth semester. We teach here in the first semester itself. So they from starting from the basics, they learn what is required, and the advanced part of the data structure we are going to do in the upper semester, higher semesters in third and fourth semester. We use data structure for teaching other courses, including deep learning courses, in the machine learning courses. Our students learn how to use the concept of data structure there.
Understood, sir. Very interesting to hear that it's still very relevant and exciting for computer science students today. So you talked about deep learning and machine learning. Now, being off track from computer science for a long, I've heard a lot about the applications, LLM, ML. Could you just share some insights on how machine learning is taught in classroom?
we do a lot of projects which are based on the concepts of the machine learning, and the student, we lot of project we do. The students who are doing the machine learning course, they come and do project with us. But most of the what I realized, in when I see my faculties teaching machine learning things, it is a project based thing. The project start from the first day of the class and they close with the end semester thing. So every concept what they learn in the machine learning is applied on one of the problem to solve one of the problem here, right? So machine learning course is the middle level course. Before that, our students will be learning AI, artificial intelligence, and they will be taking the applied deep learning track for the specialization things. Yeah.
Understood, sir. So, sir, more so in post graduation, at IIM, we had a lot of cases in class, the way you mentioned, working on projects. Could you share some examples of how you teach in classes, what kind of cases, what methodology you love, and also what students love a lot?
Yeah, this is one of the interesting thing what I follow, and also my student like recent feedback I got from students also in the recent past. For the fourth semester students, I taught a course called object-oriented programming. Right, it has lot of basic concepts which they need to know. Like starting from object, encapsulation, polymorphism, inheritance, abstraction. So lot of basic concepts which are which need to be taught to them. Right. In the past, the way I learned when I learned object-oriented programming, or the way it was taught before ChatGPT or any AI tools came into picture, we used to teach them with the different concepts, like maybe the famous example of creating the object is to tell that how any dog is different from the eagle. Maybe an example which was easy to make them understand. But after this AI tools have come, it has enabled us to explore more in the course. So what I did in the previous semester, instead of concentrating more on teaching the Java or C++, we concentrated more on the concepts. I took an example of banking application in the first class, to teach them how the objects are created, what is an object, taught the classes to everything, class access specifier to everything, and as and when we progressed in the course, same example was used for creating the abstraction. Same example was used to teach the inheritance. The concept remains same. The example case study remains same. The complexity of and the different concept students will learn as we progress in the courses, and most of the evaluations also were done on the same application. So application was not different for them. It was a not new application, was surprising application was in any of our evaluation, but they learned how to use the concept in that. Similarly, now after we don't leave the object-oriented programming there, how to apply the artificial intelligence in that application also, like the bank application I was talking about. So how to predict some fraud is happening in the bank. So you can use AI concepts there. How to get the feedback. So we can use the oops concept. Same, we thought those things in the, so stock prediction, how to predict. It is not part of the oops, but they were able to apply AI in the oops thing. So that's how the course, the way we teach the course has evolved. And programming has become very simple now. We need to concentrate more on the concepts. So That's what we are doing now. And I hope every other course also will be taught in the same manner.
It's great, sir, how this is what I would have thought in terms of learning becoming more application oriented today. Because when we were students, there used to be a big gap in terms of a lot of things we used to learn in terms of languages in the college versus when we would go into the industry, right from the campus placements and beyond. What expectation, like in our time, nobody would ask C, plus. We would spend a lot of time on that. People would ask more of Java at that point. So great that we are applying a lot. So one more thing I wanted to take your views on. Do we also go into other topics like compiler design, graphics, or even into, I remember one of my subjects I liked a lot was RDBMS. So are these subjects also still very relevant?
Yes. We'll start with the database course. Database course is the relevance of the course remains same as in the past, but the RDBMS, when we are talking about RDBMS, we use them in the output preciseness oriented applications like bank application or student data type of thing or railway ticket booking type of applications. When the output, we need a very precise output, we go with the RDBMS. But now the trend is coming with the Google or ChatGPT or any application. They don't use RDBMS there. They go for unstructured data. So they try to retrieve the data which is not part of the RDBMS. Like MySQL thing will not be able to use. So we have now new concept which has emerged as a NoSQL thing which has emerged, which can retrieve data from any unstructured thing like Google. When I'm going to, you ask for any query, it will go and it will search the entire world, servers in the entire world, and get some data. It gives you some data. Every data may not be relevant. That's what I told. The preciseness may not be the importance there, whether it is ChatGPT or Google. You will get some data. You can select from the given data. So NoSQL has come up. Even we are matured enough to understand where to use the RDBMS and where to use the NoSQL thing. So DBMS course, a 4-credit course, is taught as a RDBMS, relational database, and we have some advanced courses. We have a specialization track called full stack development, where we go for web frameworks to deployment, using the LLM type of thing in the applications like Swiggy or Ola type of thing what we are using. So there we will teach them the NoSQL part also. Here we introduce, in the DBMS course, we introduce the NoSQL, and there in the other course, full-fledged will go on NoSQL also. So database, any application require a database, and data need not be our own data. Now data is available outside. So how to use them, both DBMS, RDBMS and NoSQL both play important role. Coming to the compiler thing, compiler design is one of the important core computer science subject. But what now it has gone to elective type of thing, because most of the data science has taken the upper hand. So we need to cover a lot of things in the data science. In order to give more emphasis on the data science part, compiler has been moved to elective part. However, telling this, the concepts, what compiler, back end of the compiler, what we used to teach them in the compiler, we have split into multiple concepts. Like few things are covered in theoretical computer science course, the front end of the compiler, the parsing part, semantic part, syntax part, abstract creating the abstract syntax tree. So those things we cover in the theoretical computer course. The backend part, the target code generation, what is the target code, how compiler can be used in order to change the order for pipeline processing, avoid the hazards in the pipeline processing, is taught in the microprocessor course, where when we teach the pipeline, we teach what is the role of the compiler there. Similarly, when we teach in the deep learning course, when we are going to deployment, how the backend code is generated for CPU and GPU, how compiler can be used to segregate the code, which part of the program should go to CPU, which part of program should go to GPU, which compiler will be doing. We teach them along with the course. We have not left out the compiler totally, but we have created multiple modules and we have spread across multiple courses. So we cannot leave the compiler.
Yeah. Definitely, sir.
Yeah.
So I have another question, but before I go to it, just again as a student a question. Is microprocessor 808586 still a part of learning?
8085, 8086 is not part of the learning. Now we have moved to ARM processors, like the processor which are used in your mobile phones, which are used in the robotic applications, and the ARM processor which Intel's processor follows. We teach them. 8086 is not, I will not tell that it's not relevant, but the ARM processor falls in the same hierarchy. So 8086, 8085 are the ancestors of the processor what we have. So we teach them. Even we have a we have course called Computer Architecture and Microprocessor.
Okay.
So we teach them the instruction set ISAs of ARM processor, which is current, not the 8086, which are not there now. Even Pentium 4 we don't use them. The ARM processor with the pipeline thing and the multi-core concepts, how two processor can be on the same chip, how they communicate, those type of things will be teaching. Again, microprocessor as a word. In the computer science, we are not bothered about designing the microprocessor. We are not involved in designing the microprocessor, but we need to ensure that our students know what program they are writing today, how it will run on the processor. If they don't understand, they will not be able to optimize. That is the only catch there. So they need to know how the program run on the processor. So they should be able to process that. That's what we teach the course, microprocessor. We call microprocessor and computer architecture is the course what we teach in Vidyashilp University.
Great, sir. So, sir, coming to the next question then, do we also have some group assignments or projects where students collaborate, work together as a part of any of your courses or as a part of general the pedagogy that we follow at school?
Yes. Most of the courses, especially in School of Computational and Data Science, we don't have a written end-term examinations. So most of the courses are project-oriented courses, like the object-oriented programming course, what I told, machine learning course, deep learning course, visualization and data, storytelling using the data. There are few courses which are not written-oriented thing, which are all project-based. So we follow the continuous assessments. The continuous assessment in all these type of courses are project-based. So a lot of students collaborate to do the project. They form the group and they will be doing the project. And the question people normally used to ask, challenging to evaluate which student has contributed a lot. So we teach them the modular programming. So we make module owners. So and we expect everybody to incorporate all the concept whatever is taught in each modules. In that sense, we are ensuring that students also learn when they are doing the project, and they learn how to build a code in the modular way and to make two modules work together. So yeah, most of the course follows this, including database, including object-oriented programming, machine learning, deep learning, and any other course like we are planning in the future also will follow the same format.
Understood, sir. That's great to hear because I feel a lot of learning happens when students collaborate.
Yes.
Peer learning is an equally important part,
Correct.
especially in computer science. I feel again a bias because being a computer science engineer, we are often about applying brains, thinking, structuring.
One more point here is it is not only the computer science student collaborate with computer science students.
Okay.
We have a lot of course which are having minors. So we have psychology student is collaborating with computer science student. Finance student is collaborating with computer science students. I have one student, Pawan, is an artist doing data science, B.Tech data science. He has taken minor as design. I have seen him collaborating with the design students to create the art. So those type of collaboration is one of the best thing you will see in Vidyashilp University.
Yes, sir. I think that really makes the 4 years of learning very valuable.
Yes.
When they are able to apply cross disciplines.
Yes.
True. So another memory from my undergrad days, we were based out of East India. So IIT Kharagpur robotics event used to be a big buzz there, and months in advance. First, at the intra-college level, students will start working on robotics, then try to pitch it to the zonal event in that way. So, does that charm of robotics still exist?
Yeah. So even when we started Vidyashilp 2021, we got the approval. 2022 we started, and we started with the dream that we should have a robotic lab in Vidyashilp University. So we have something called Makerspace, and 2 courses in Vidyashilp, like Introduction to Digital World and Design Workshop type of course, which we designed to teach the basics of how to build the robot. And your question of relevance, yes, it is very relevant when you are talking about in the AI domain. There are a lot of robot is not simple mechanical or electronics component nowadays. Now we need to build a lot of intelligence into it. When you are talking about AI, in the first year we teach students how to water the plant. I used to tell them build a robot which can pour the water in the corridor from this end to that end. And next question I used to ask them, like after the course I told them that now it is your responsibility to build a robot which will water the plant only if it is required, which is a challenging thing. If it is required. So now robot should take a decision. To answer this, you need to complete your AI course, you need to complete your deep learning, machine learning course. So your robot understand. So you need to build the AI concept on the robot. If you want your robot to take decision or you want your drone to take decision, you need to build the intelligence. So robotics and AI go hand in hand. So yeah.
Yes.
And just to elaborate our discussion, like we have a few students who have participated in the national level event called Anveshan recent past, last semester. So 4 of our projects we presented in the national level, and one of our project got selected in the international level also. So the Anveshan 2025.
Could you tell us a bit more about the project?
4 project. First project was MEERA, the robot what we are building here in Vidyashilp University. It's a MEERA is a mindful, enthusiastic, enduring robot assistant. It is for the patient assistant or old age people assistant robot which we are building here. That is one project what we are building here. Next project is called LARA, legal aid assistant robot. So we call it as a LARA. LA stands for legal assistant robot automation. Then we have one more robot called ISFER. It is we are building it for the crime scene investigation. And for the MEERA, full humanoid robot we are building, and we were building the head, chest, everything, and we started building the hand. And we realized instead of only going for using hand only for serving purpose or helping purpose, we'll build the intelligence to the hand. So we started building a hand which can be used for forensic sketch. That is the one which got selected for the international level. So a lot of good process are happening. Hand building a intelligent hand to read or to understand the description given by the witness and to draw the sketch description plus the past intelligence it can use, and it can draw the sketch of the person who is involved in the crime. This is the project which we are working on, and this is the one which had gone for the international.
Wow, this is so amazing to hear, because the way you explained it. So our time it was more about mechanical robots, basic activities, robo wars. That was the domain. Now intelligent robots, and that too, I believe this exposure for students is what bridges the gap between academia and industry.
Correct.
It's really impressive.
Yeah, when we started, we had promised 4 years. We told them it's a 4 years plan. So building a robot is not one day thing or one semester thing. We need to learn from the first semester, and we need to take till the last year, so that you can show to the outside world, yeah, I have done something industry. So instead of showing the resume, we can show the product itself at the end of the
That is so great.
Yeah.
Another question related to robotics, but in terms of how we engage. I read you have also engaged with students on AR VR. So what's that been all about?
Yeah, AR. We did not get into the VR part, but AR we started from the beginning. We have a parallel course to design workshop called Introduction to Digital World, where we this is for other domains like management, psychology students, design students, law students do this course in their first semester. So we teach a lot of low coding, no coding tools to those students, because they don't want to write program. But so there are some tools which does not require coding. So we have identified a lot of tools like that, starting from website creation to building the chatbots, and building 3D models, and building the AR thing, augmented reality thing. So people used to question us why they are learning. So later on, the management students or the design students, they realized learning the AR will improve their presentation skills. Like they realized like the spec speaker type of thing, or the urban ladder, they use AR to give the user experience without visiting their store. They can use their mobile, or they can use their laptop, and they can design the interior of their house. Similar type of applications our students started doing from their second semester, using the augmented reality. After the course, they come to me and they tell that they will be using this AR part for in the digital marketing course or any other exhibition. When they go, instead of going only with the posters, they give a real-time experience to the audience using the knowledge tools, whatever they learned using the augmented reality.
I can very much connect with it, sir. Even apps like Lenskart, Nika, everybody is using it now.
Now people used to run away from this, or people don't touch this concept. I'm telling the non-B.Tech students, because they think that a lot of coding need to be done. But we have a lot of tools. Without doing the coding, they can create these type of applications.
So one more question on this, sir. What are the new tools that are in B.Tech computer science today? What was not there maybe in my time, 2 decades back? What are the new things?
Other than this introduction to digital world, the low coding, no coding thing, what I was telling, that during our days, I think we are from the same, like in early 2000 or late 90s, Um, uh, Most of the tools were proprietary. We were not able to dissect the code and software, and we never saw what is inside. Now, lot of things have come where we can open. They are open source. Now we can dissect the code, even from the operating system to scheduler, whatever we have. We can dissect thing in the operating system course or in the uh, microprocessor course. We can open the operating system and we can show them what is there inside the operating system. That was the core computer science, and a lot of simulation softwares which have come, which will simulate the exact hardware. They can visualize what is happening at the multi-core level, what is happening at the pipeline level. And coming to the data science, specific to data science, there are a lot of tools. The Python being it started as an education software programming language used for teaching. Now it has grown a lot, which can be used for developing the software. So a lot of tools, libraries, what we did not have during our days. Those libraries, like starting from Panda, PyTorch, Scikit, TensorFlow type of things, they can we teach them in the class, as well as the visualization tools like Power BI.
R and Tableau
Tableau,
these
yes,
also?
yes. Python and R go hand in hand. We teach a course called probability statistics. For us, probability statistics was mathematics. We used to do it, everything we used to do it on the paper. Now, probability statistics, we cannot teach without the R programming language. We teach them R, we teach them Python. So, yeah, to understand those things.
Sounds very exciting, sir. So one last question. What will be your word of advice to students who are looking for a career in B.Tech computer science, data science today in their lives?
So one thing we should not forget is data science is part of computer science. Core computer science things, whatever is required, we need to learn. It will help us in long journey. Instead of concentrating only upper cream of the data science, we need to touch the lower level also. Computer science, core computer science things we need to concentrate on. Second thing, we should not forget the mathematics. Vidyashilp emphasize more on teaching the mathematics in every course. You cannot forget the mathematics, calculus, linear algebra, probability and statistics, because these are all the base for building the data science. And that is computer science thing. When it comes to data science, data is huge, and you have access to a lot of data. We should be more responsible. If I am calling myself a data engineer, I have more responsibility how I am going to use the the data. Right? We should be more ethical. We should be more legal in using. And data science, the biggest challenge in the data science world is the pace at which the technology is changing. We should, as I told, we should be very relevant. We should be very connected. When it comes to research, we should be doing research every day, and most importantly, I think we should be connected with the data science community outside world, just to understand what is happening. If you don't understand what is happening outside world, whatever we learn here will become irrelevant.
Thank you so much for your words, sir. It was great to hear and appreciate how research, learning, development, and cross-disciplinary application as well. All those things are at the forefront of how learning is approached. Thank you for your time. I learned a lot. I hope all our viewers who have interest and aspiration to contribute to the field of data science and computer science would have learned a lot as well. Thank you very much.
Thank you very much. Thank you.
Thank you, sir.